This video displays a proof of concept for using sensing technology to alert, and if necessary, correct for drivers who drift out of their lanes and to reduce the number of automobile collisions. There are approximately 27,000 auto accidents each year. This number can be reduced greatly by implementing sensors on the exterior of the vehicles. One type of sensor could measure the distance the vehicle is to the edge of the road by identifying the yellow and white lines. When the vehicle gets too close to the line, a beeping noise can alert the driver. Additionally, the vehicle can use automation to gently assist the vehicle back to the center of the road, but not to the extent that the driver cannot control the vehicle out of the lane if required in an emergency. Distance sensors can be affixed to the front and rear of the vehicle that will identify the distance of the vehicle in front and behind it. If the vehicle in front comes to a sudden stop, the computer reading the sensor signal can react faster than a human reacts and stop the vehicle before collision occurs. If the rear sensor detects an impending rear-end collision, it can attempt to move forward, if possible, to either reduce or eliminate damage. This vehicle uses a standard remote control car chassis, suspension, steering, and throttle assembly. The throttle and steering headers were detached from the receiver module in order for the signals to be manipulated for the aforementioned purposes. An infrared distance sensor was mounted to the front end of the vehicle. That sensor sends an analog signal depending on the distance of an object in front of it. There were capacitors added to reduce the noise from the sensor, which improves the controlled response to changes in the signal. The Arduino microprocessor board uses a proportional gain controller to output a pulse width modulated signal to an electronic speed controller. The electronic speed controller then interprets that signal and determines the appropriate voltage to send to the drive motor. A camera is mounted on the front of the vehicle. The specific camera is called a pixie. It is taught to recognize different hues. It will identify segments in its field of view where that hue is found. These segments correspond to an analog voltage that is used to determine the input to a controller. The camera is mounted on a pan-tilt servo assembly that is controlled through a PD controller, which adjusts the camera location. The PD controller is built into the Pixie libraries for Arduino, and the Pixie has pins specifically for supplying power and signals to these servo motors. The controller signals the servos to move the camera to position the detected object to the center of the frame. For this prototype, the camera was taught to recognize the color blue. This color corresponds to the blue painter's tape, which is used as the guiding strip. The signal sent to the pan servo is red, and a gain is added for a control of the vehicle's steering servo. The vehicle steering servo will attempt to make the difference between the angle of the pan servo and the center point of that servo to be 0. This is accomplished by angling the front wheels accordingly and moving the vehicle forward.
You gonna do? Yeah. Bad boys, what you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do? What you gonna do when they come for you? When you were 8 and you had bad traits, you go to school and learn the golden rule. So why are you acting like a bloody fool? If you get hot, then you must get cool. Bad boys, what you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do? What you gonna do when they come for you? You chuck it on that one, you chuck it on this one, you chuck it on your mother and you chuck it on your father, you chuck it on your brother and you chuck it on your sister, you chuck it on that one and you chuck it on me. Bad boys, what you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do?